So what are the 10 pillars of integrative design? Well, they're a web of interrelated elements that for now we can organize into 10 pillars or principles on which your design exercises, your puzzler solutions will build. By the way, do you know where this image of pillars is from? La Sagrada Familia. Yes, it's the breathtakingly beautiful cathedral in Barcelona by the Catalan architectural genius Antoni Gaudí. It's like a giant stone forest. Now, do you happen to know how he did the structural design of those soaring stone arches and vaults and pillars long before we had computers? Well, you can go down to the basement and see an upside down physical scale model with strings or fine chains suspended from posts so they would hang down in catenary curves, equally distributing their gravity-induced tension along each chain. Then he photographed those curves, traced them on paper, turned the drawings right side up again, and built the stonework to that pattern so the compressional loads in the stone would also be evenly distributed. Wow, that's beginner's mind. So what are these 10 pillars of integrative design? Well, the first one, the starting point, is to cultivate beginner's mind. It's never too early or too late to start. It's the hardest and most essential step, and this course is going to make you a lot better at it. A second starting point is to transcend disciplines. Blow up silos, or as we call them in academia, cylinders of excellence. If you can't destroy them, span them, or simply ignore them. Knowledge has no boundaries. Those lines on the map are just artifacts of academic tribalism. Deep topical knowledge is vital, but you can't understand the world and navigate it safely just through a microscope. You also need a wide-angle lens to see where you're going and what's coming at you. Without vision across boundaries, the people perish. Those two starting points let you get to work by focusing first on the purpose, starting with intent, with the effect you want to achieve. Think why before you think how. If you start with the end use, the service you want to deliver, then you will naturally learn to put efficient use before greater supply, passive methods before active, and simple means before complex. Fourth, having started at the end with the desired end use, work backwards or upstream from there. So when you start your savings at the downstream end of a chain of compounding losses, and as in this power and pumping system, you reverse those compounding losses into compounding savings going back upstream. That saves a lot more energy at the front or upstream end, and it also often makes all the components in between smaller, simpler, and cheaper. So in this pumping system diagram, energy is flowing from left to right, from fuel at the power plant to flow out the pipe, but efficient design should flow from right to left. The fifth pillar comes from, among others, General, later President Eisenhower, who said, if a problem can't be solved, enlarge it. Don't chop it into smaller bite-sized pieces, but move the boundaries out to include more options, more synergies, more degrees of freedom, until it encompasses what the solution requires. You'll learn by doing that this simple idea is astonishingly powerful. Sixth, optimize buildings, factories, equipment, vehicles, anything you design as a whole system for multiple benefits, not as a pile of isolated parts for single benefits. So here's the middle of my house, the banana farm. This atrium where we've so far harvested 83 passive solar banana crops and about 100 kinds of tropical fruit with no furnace in a subarctic climate at slightly lower construction cost. This white arch at the top has 12 different functions, but it has only one cost. Seventh, simplify. Take stuff out. Take more stuff out. aim to do almost everything with almost nothing. Somebody asked Michelangelo, "How did you sculpt David?" He reportedly replied, "Oh, it's simple. I just chiseled away everything that wasn't David." Well, as you'll learn, sculpture's subtractive technique runs counter to a deep-seated human bias for adding rather than subtracting. So when you try to chisel away thoughts rather than stone or wood, it does get harder, but you'll learn how. Pillar 8 is the first of 3 suggested methods or tools. It guides you to follow 3 rules with data. The first is measure, don't guess. Rules of thumb might help in designing thumbs if that hadn't been done already, but it's a pretty poor way to design anything else. Without measurement, you can't know the right size or how much is enough. My mentor, Liang Lok in Singapore, says if jumbo jets were designed the way most people design cooling systems in big buildings, those airplanes would have an extra set of engines and a spare set of landing gear just in case, and they'd be really safe because they'd never get off the ground. The proverbial drinking glass is neither half empty nor half full. It's simply twice as big as it needs to be. Second, it's not enough just to use measured data if they're old and lack trajectory or a sense of where they're heading and why. As the hockey great Wayne Gretzky said, you need to skate where the puck is going to be, not where it has been. Third, keep your data and your understanding fresh by making your systems smart, with continuous measurement, feedback, learning, and improvement. Always updating your parameters, architectures, decision logics, because systems without feedback are stupid by definition. Here's a diagram of Colonel John Boyd's OODA loop, which tells you to observe, orient, decide, act. In other words, see what's happening, consider what to do about it, choose, act, and repeat. That's at the core of military tactics, because if your loop is faster than your opponent's loop, you win. So you try to make your loop faster and your opponent's loop slower. The same is true in business competition, and it's vital to our efforts to outrun the crises we've created. Pillar 9. Understand the minimum energy theoretically required to do your task. Figure out why normal design, even best design, use more than that, and then systematically trim the difference, reduce the waste. Along the way, you may even find that doing a different and easier task instead can better fulfill the ultimate purpose you defined in Pillar 3. Like maybe instead of improving the lighting system, open the curtains. Then once you've pared to essentials, don't add back padding on the supply side. Designed to tolerate rare conditions, often by smarter means than enlarging supply, but optimized for the conditions that occur most of the time. And 10th, learn from many teachers, especially from nature's 3.8 billion years of design experience, like this car modeled on a boxfish, or Japan's 500 series Shinkansen bullet train. It cut air resistance 30%, energy use 13 to 15%, by reshaping its nose like that of a kingfisher. You can see at the far right diving from air into water, which is 800 times denser, with no concussion and scarcely a splash, thanks to a specially evolved shape on its beak. Also, adding small shapes to the main part of the pantograph, the arm that captures electricity off the overhead wires, turned its one big air vortex into many little ones, like the way an owl's primary feathers do for silent flight so the mouse can't hear it coming. All this happened because the senior train engineer I happened to meet, Nakatsu Eiji-san, happened to be a bird watcher. More later on such biomimicry. Meanwhile, please check out an amazing and gorgeous free online journal called Zygote, Zygote Quarterly. You will be astounded.